Hi everyone. Today we're going to go over some supplemental notes on completing the square so we feel comfortable graphing or applying this process to graphing. So remember, our goal of completing the square is, at least in this case, to be able to write the equation of a circle that looks something like x plus or minus some number, quantity squared, plus y plus or minus some number, quantity squared, and that will equal our radius squared. Okay, this helps us find the center of the circle. It helps us find our radius. It's the best form to graph a circle. So completing the square sometimes helps us write problems in this form when we have binomials and trinomials instead of a factored form. Now, notice in that equation for a circle that I just erased, you had binomials squared, which hopefully reminds you of a certain special factoring case, which was called a perfect square trinomial, which is where you have your first term squared plus or minus 2 times your outer term and your middle term, the square root of them, plus your last term squared. This is a perfect square trinomial. The first and last are perfect squares. The middle one is 2 times your a times your b. And this always factors to the form a plus or minus b squared. So if you recognize those, it's a really easy factoring shortcut. And this is exactly what we want our circle formula to look like to help us graphing. So our goal of completing the square is to create a polynomial that looks like this instead of these binomials out here. So let's practice this process. And we're going to start with the x's just to start with our first problem. So I'm going to rewrite them over here. Now remember, our goal is to write a trinomial, so I'm going to leave a blank for my third term. And if you want it to look like this form here, your last term is going to have to be a perfect square, just like our perfect square trinomial. And your middle term has to be 2 times a times b. In this form, with the x squared, your a is actually a 1, because there's no coefficient written there. So if I rewrite the perfect square trinomial formula, it's really a squared plus or minus 2 times a, which is just 2, because your a is 1, 2b, plus b squared. Okay, so I just kind of replaced this a with our 1, because we're working with the coefficient of 1 here. So if this middle term is 2b, that means this is 2b. So in order to find just b, we'd have to divide this term by 2. And negative 10 divided by 2 is negative 5. Watch your signs, keep the sign with it. Now if we want to fill in this last term, remember our last term has to be b to the second power. So what we want to do is take our b term and square it. And that's what's going to fill in our blank here. Now this whole term is a perfect, didn't want to erase that much, a perfect square trinomial, because it's of this form up here. Okay, so now that we've kind of filled in our blank, remember our goal to write a perfect square trinomial is because it factors into this form. So now I can rewrite this as my a plus or minus my b, in this case b minus because of that negative sign there, that subtraction sign, and my b we said was negative 5. So there's my negative 5, and that whole thing is squared, and we factored it without much effort. And this is really helpful, again, to writing the equation of a circle. If you don't trust me that this factors correctly, you can always FOIL it out, guess, and kind of check it then. Let's do the same thing for our y terms over here. So we have y squared plus 6y plus some blank here when we create our perfect square trinomial. So first thing you want to do is find your b. So you're going to divide 6 by 2, and you would get 6 divided by 2 is 3. Then you want to square it, and then you fill it in your blank. So this is just going to be a 9. So our b is 3, our b squared is 9. Now we can factor this to be a perfect square trinomial, which factors to y plus or minus your b term. In this case, our b is positive, so it's y plus 3 quantity squared. These are equivalent expressions here. Okay, so putting that all back together, we just factored to have the equation of a circle. That's x minus 5 squared and y plus 3 squared, which is going to give us our center of our circle. Now, I only worked with these parts here. It's still equal to 24. There's one step we're missing. I just worked on writing our perfect square trinomial. But notice, if I compare this and this problem to my original problem, I have a 25 here that is not in the original problem, and a 9 here that's not in the original problem. So basically, into this problem, I added 25 and I added 9. Now, if I just add in random things to a problem, it's going to change what the problem is unless I account for it by doing the same thing to both sides.